Welcome back, students. Welcome to Talk on Civil Engineering. Let us see how we can analyze flanged sections. Here we are going to find out the moment of resistance. So this moment of resistance for a flanged section usually depends on the depth of neutral axis. So depth of neutral axis. So where the neutral axis is existing. So based on that, the analysis will changes. So that means, so for a T-beam, you will be having a flange section and web. Okay. So if the neutral axis is existing in the flange, so that means this is, this is a depth of flange df. Okay. So if xu neutral axis is less than df, less than or equal to df, so that means it is the neutral axis is existed or it is existing in the flange. Okay. So this is one case, and another case is if xu is existing in the web, so that means the xu is greater than the depth of flange. So if the xu, the neutral axis is greater than the df, that means it is existed in the, it is falling in the web, right? So based on this, the analysis or the finding of moment of resistance will changes. Okay. So the analysis is also provided in IS 456, but you need to have basic idea or basic knowledge, basic procedure of how this analysis or how this moment of resistance formula is derived or got. Okay. Now let us consider the first case, that is where let us assume that xu, that neutral axis is within xu, that is neutral axis is within the flange. Okay. So that means xu is less than or equal to df. So if this is the case, IS 456 is recommending to design the section simply has a rectangular section. So let me open the IS 456 code also. So here in G2, in page number 96, in G2.1, so for xu less than df, the moment of resistance may be calculated from the equation given in G1.1. So G1.1, is about rectangular section, simply a rectangular section, right? So simply a rectangular section of singly reinforced. So using that procedure, you can find out the moment of resistance, or you can design the flange section. Okay. So if xu is less than df. Okay. So in this case, what we are considering, so the design is based on or considering flange section. Flanged section has rectangular section. Okay. So that means here the width of beam, rectangular beam, will be the effective width of flange. Okay. So for suppose if this is a T beam, this is a T beam height, and we know this is your width of flange, depth of flange df. Okay. So somewhere here your xu, so that is within the flange, so your xu is existing. Okay. So that's how the stress diagram will be. So the stress diagram in the concrete, the concrete stresses or compressive stresses will be there up to xu itself, right? So it will be there up to xu, that is within the flange. Okay. So here you will be having C, and here you will be having T, and the compressive forces will be same like a rectangular section, that is 0.36 FCK and XU into B. So this is a compressive force in the for a rectangular section, right? And what is the tensile stresses or tensile force? 0.87 Fy into AST, right? And you know, this is 0.42 XU, and what will be the lever arm? So the lever arm is equal to D minus 0.42 XU, right? So in order to find out the moment of resistance or XU, so firstly you have to find out the XU by XU to check whether whatever we have assumed is correct or not. Okay, so మనం XU is less than or equal to DF అని అనుకున్నాం కదా. సో మనం అజ్యూమ్ చేసింది కరెక్టా కాదా అని చెక్ చేయడానికి ఫస్ట్లీ యూ హ్యావ్ టు ఫైండ్ అవుట్ XU. So for a rectangular section of singly reinforced, how you will find out the XU? By equating C with T. By equating both the forces, we can find out the XU, right? So what is C? C is 0.36 FCK B into XU is equated with the tensile force 0.87 Fy into ASC. So here XU will be 0.87 Fy into AST divided by 0.36 FCK into B. So using this formula, we can find out what is the neutral axis. Okay, and here we can compare this whether this is less than or equal to the depth of flange DF. So if this condition is satisfying, whatever we have assumed is correct, and the procedure, the design procedure or analysis procedure is also in the right process. Okay, so if it is satisfying, okay, then we can go for the moment of resistance. So how we can find out the moment of resistance? C, the compressive force or lever arm, or T into lever arm. So that's your wish. So if C into lever arm, so what is the formula? 0.36 FCK B into XU, and the lever arm will be D minus 0.42 XU. Okay, so with this formula, we can calculate the moment of resistance. Okay, and in case if you want to find out the AST, so you can use the another equation, that is 0.87 Fy AST lever arm D minus 0.42 XU. Okay, you can use this formula, or else if the moment is known and you have to find out the AST, area of steel required for the flange section, therefore then you can use the another formula, that is moment of resistance is equal to 0.87 Fy AST D 1 minus the steel parameters, that is Fy into AST, and the concrete parameters, that is FCK into B into D. Okay, so you can use this formula to find out the AST if moment is known. Okay, so this is the first case, and if the second case, if it is a second case, that is if the condition is not satisfying, that is neutral axis is less, it is exceeding DF, at that you will go to the case 2. So case 2, that is if XU is greater than the DF. Okay, that means the neutral axis is lies in web. Okay, so if this is a case, so you have to recalculate XU, recalculate the neutral axis by assuming so XU is greater than DF. Okay, so if this is the case, if XU is greater than the DF, the another two cases will arises. So if XU is greater than DF, so another two cases will arise, that is one, so XU is greater than DF and the DF is less than or equal to 3.7 of XU, or as per IS 456, DF by D ratio is less than or equal to 0.2. So this is the first case. So okay, XU is greater than DF unte, this will be your first case. And the second case, so XU is greater than DF, we know that, okay, and DF is greater than 3 by 7 of XU. So what is 3 by 7 of XU? That we have already discussed. Okay, so 3 by 7 of XU is, so if this is a stress distribution in a concrete up to the neutral axis, so this rectangular portion will be there. So this rectangular portion will be there up to 3 by 7 of XU, and this parabolic portion will be there up to 4 by 7 of XU. Okay, so we are considering that this rectangular portion is within the flange ones and exceeding the flange ones, flange depth. Okay na, ఒకసారమ ట్రయాంగులర్ పోర్షన్ ఫ్లేంజ్ డెప్త్ లోపే ఉంది అని అజ్యూమ్ చేసుకుంటున్నాం. ఇంకోసారి ట్రయాంగులర్ పోర్షన్ అంటే 3/7 ఆఫ్ x ట్రయాంగులర్ పోర్షన్ ఫ్లేంజ్ డెప్త్ కంటే వెబ్ డెప్త్ లోకి వెళ్తుంది అని అజ్యూమ్ చేసుకుంటున్నాం. సో దీస్ ఆర్ ద టూ కేసెస్. Okay, right. So DF is greater than 3/7 of XU, or as per IS 456, DF by D is greater than 0.2. So these are the two cases. Okay, so let us see the first case, that is XU is greater than case 1. Okay, so that is XU is greater than DF and DF is less than or equal to 3/7 XU. Okay, and as per IS 456, so DF by D is greater than 0.2. Okay, so if this is a case, that means the rectangular portion, so the rectangular portion of stress block diagram is within the flange section. So is within the flange. Okay, so for this, how we have to design is, so if this is a T beam, so if this is a T beam, okay, so we have to divide this into a flanged section as well as a rectangular section. So this is a flanged rectangular section, 2 is my flanged section. Okay, and somewhere here you are having the XU. Okay, and how that stress block diagram will be there? So here you have T, and the rectangular portion will be there within the flange itself. Okay, so within the flange itself you will be having the rectangular portion. So this is how your stress block diagram will be there for the case 1. Okay, and this will be the rectangular portion depth will be 3/7 of XU. Okay, and you know that this is 0.45 FCK, right? And for designing case, so the designing is similar, just we have divided into two separate section, one is flanged and is rectangular. Okay, so for rectangular, so this is a rectangular, so for rectangular portion the stress block diagram will be same, right? So the stress block diagram will be something like this. Okay, so you will be here, you will be having C1 and here you will have T. So C is equal to 0.36 FCK B into XU. So just like a rectangular section. And another you will be having flanged sections. So something like this. So here you have a rectangular section that we have already considered. So for flange section, how is the stress block diagram? You are having only the rectangular portion, something like this, right? Only the rectangular portion. Okay, and the depth of this rectangular portion is this is 3 by 7 of XU. Okay, and this is 0.45 FCK. Okay, or else since this is since we are assuming, so this df is less than or equal to 3 by 7 of XU, so we can equate that. Okay, so this is this value. So df is less than or equal to 3 by 7 of XU. Okay, and here you will have T. Okay, so at the center the C2 is acting. Okay, now we have to find out this C2 so that we can, the compressive forces will be summation of C1 plus C2, right? So let us take this how we can calculate the C2. Okay, now let us find out the position of neutral axis. In that itself we will find out what is C2, neutral axis. So by equating C with T. Okay, so C will be C1 plus C2, right? Or compressive force in web plus compressive force in flange plus compressive force in web. So this is the compressive force in web, right? So this is the compressive force in flange, right? So is equal to T. So compressive force in flange, how we can find out? The area will be the area will give you the compressive force in flange, right? So the width is 0.45. The width is 0.45 FCK. Okay, into the area. So the stress into the area. So the stress into area will give you the force. Okay, so stress into area. Okay, so stress is 0.45 FCK. That is from top to up to a depth of df is constant. Okay, so what is the area? So depth is df, and what is the width? So width is, so this is this is complete bf. Okay, and this is bw, width of web. Okay, so from effective width of flange, if we subtract the width of web, we'll get the width of both the flanges, right? So bf minus bw, అంతే కదండి. సో width of web ని width of flanges నుంచి తీసేసాను. తీస్తే మనకి ఓన్లీ width of both the flanges వస్తాయి. Okay, so this is Cf, that is the compressive force in flange, plus the compressive force in web is just like a rectangular section, so it is 0.36 FCK B into XU. So it is equal to T. T is 0.87 Fy AST. Okay, so I have taken this as common for both. So రెండు sections ki T common అనుకుంటున్నాను, అందుకే only single formula రాసాను, right? Now we have to find out XU, right? So let us send this term to that side. So it will be 0.36 FCK B into XU is equal to 0.87 Fy AST minus 0.45 FCK df to bf minus bw. Okay, so we need to find out XU. So XU is equal to 0.87 Fy AST minus 0.45 FCK df bf minus bw divided by 0.36 FCK into B. So using this formula, we can calculate or we can find out what is the neutral axis, and we can check whether whatever we have assumed is correct or not. So now we have to check if the assumed is correct. Whatever we have assumed is correct, then we can calculate the moment of resistance. Okay, so what we have assumed, so that is also important. What we have assumed, the XU is greater than df, that we already know, but the df is less than or equal to 3 by 7 of XU. So this is important, and not only the df by d should be less than or equal to 0.2. So if this is satisfying, whatever the procedure we have proceeding is correct, we can go for the moment of resistance. Okay, So how we can find out the moment of resistance? So moment of resistance is equal to C into lever arm, right? C into lever arm. So here, so for flange section, what is the lever arm? So you know this is this compressive force of flange is acting at half of df, right? So half of df. So half of df. So this is the lever arm, right? So d minus half of df. This is a lever arm. Okay. And for a rectangular section, we already know this is d minus 0.42 xu. Okay. So now let us find out the moment of resistance. So it is equal to Cf into lever arm, the compressive force in flange into lever arm, plus the compressive force in web into lever arm. Okay, lever arm of flange and lever arm of web. Okay, so lever arm at web, right? So let us substitute these values. So the compressive force in flange already we have written. So 0.45 FCK, 0.45 FCK into df into bf minus bw. So what is the lever arm? Lever arm is d minus df by 2, right? Plus cw is 0.36 fck b into xu, and lever arm will be d minus 0.42 xu. Okay, so this is a moment of resistance formula. Okay, so using this formula we can find out the moment of resistance if it is case 1. Okay, in case if the condition is not satisfying, that or whatever you have assumed is not satisfying, that is, then we go for the case 2. Case 2, that is xu is greater than df, we know that, but the df is also greater than 3/7 of xu, or as per IS 456 df by d is greater than 0.2. So at that condition, at that case, we'll go for the case 2. So this is my case 2. Okay, so that means the effective, the depth of flange is greater than the rectangular section. You can, from this figure you can observe, so that this is the depth of flange, right? So the depth of flange is more than the rectangular section. Okay, so the more than the rectangular section, so somewhere in the within the flange you are having the rectangular section, whereas in case 1, what happened in case 1? So in case 1, the rectangular portion is less than or equal to 3/7. That means the rectangular portion is greater. So this 3/7 xu is, in the sense, it is a rectangular portion. Okay, so the rectangular portion is greater than or equal to the depth of flange. Okay, so in that case we can simply simply separated the both the sections and we have calculated. So whereas here the depth of the flange is more than the rectangular section, rectangular stress block. Okay, so that means, so somewhere within the flange you will be having the rectangular portion, and not only that, so here if you see, this is you will be having less 0.4, less than, the stress is less than 0.45 fck, right? So stress is slowly reducing from 0.45 fck to the 0, that is started within the flange itself, right? So for this condition, for such condition, IS 456 is recommending to use YF. So here YF is the modified thickness of flange. So we are modifying the thickness of flange. Okay, so IS 456 is recommending to use this YF instead of DF in the same formula, that is in case 1. So in the same formula, instead of df, we are substituting the yf. Okay, so let us write, let me show that formula for you. So if this is a case 1, you can use this formula. So it's the same formula that we have derived. So in xu, he has some substituted xu max by d. That's it. Okay. So in case if it is a if df is exceeding 3/7 of xu, that is case 2. So at that condition, you have to substitute in place of df, you have to substitute yf. So here you can see yf is there, yf. Okay, so yf is substituted. So what is yf? Yf is equal to 0.15 xu plus 0.65 df. Okay, so this is a condition when df by d is exceeding 0.2. Okay, so these conditions won't be there in your formulas. Like 3/7 of xu is xu అనేది మీకు కోడ్ బుక్ లో ఉండదు, but it means that it means same. So df by d is greater than 0.2. Okay, so కొన్ని competitive exam లో I will mention like this. Okay, so 3/7 xu అంటే ఇదే. So here you can see 0.43. 0.43 అంటే 3/7 of x, 3.7, right? Okay, so he will mention like this, right? So if this is the case, we'll modify df with yf. So let us write the same formula. Moment of resistance is equal to 0.45 fck. So in place of here you will get the df. So in place of df, you have to substitute yf into bf minus bw. To lever arm is d minus df by 2. So instead of df, you have to write yf. So yf plus 0.36 fck bw xu d minus 0.42 xu. Okay, so you can use this formula to find out the moment of resistance in case of case 2 like this. Okay, so I hope you have understood. Once again, you can have a look. Thank you all.